Example, we have number 1, write the 4 ways of representing an alternating current voltage or AC voltage given by a magnitude of 5 volts and frequency of 50 hertz. So the 5 volts here is the RMS value or the effective value. Since it is not stated that 5 volts is not the maximum, so that is your ERMS. So recall natin yung mga equations na diniscuss natin sa part 1. So ito yung mga yon. E is equal to EM sin theta. E is equal to EM sin omega theta. E is equal to EM sin 2 pi ft. E is equal to EM sin 2 pi time over period. So for our first example, we have RMS 5 volts and frequency equal to 50 hertz. So ang kailangan natin ay E maximum. To solve E maximum, we will multiply the ERMS to square root of 2. So EM is equal to 5 volts times square root of 2 equal to 7.071 volts. This is the diagram or the representation of the sine wave of sine equation. We have the maximum voltage here and another one at the negative half cycle. So E maximum na solve natin, that is 7.071 volts, while the RMS is 5 volts. Nandito yung effective voltage, as well as in our half cycle. So formulating now the equations, 4 equations. E, instantaneous voltage E, is equal to 7.071 sin theta. E is equal to 7.071 sin omega t. Next is E is equal to 7.071 sin. Our omega is equal to 2 pi f multiplied by the time. So 2 pi f times 50 is 314.16 t. So we have 7.071 sin 314.16 t. Last equation is E is equal to 7.071 sin 2 pi multiplied by time divided by the frequency, kasi F is equal to 1 over T. So T is equal to 1 over F. So over 50 hertz. So these are the 4 equations. Number 2, an alternating current of frequency 60 hertz has a maximum value of 12 amperes. So our 12 amperes now here is maximum. Hindi na natin kailangang multiply pa ng square root of 2 kasi naka-maximum na. So our first equation is I is equal to 12 sin theta. Next, I is equal to 12 sin omega t. Next, I is equal to 12 sin 2 pi times 60 times t, so that is 376.99 t. 12 sin 376.99 t. Last one is 12 sin 2 pi multiplied by the time divided by the frequency. So here is the representation of sine wave for this equation. So ang wave na to, ang equation niya ay etong 4 na to. So let's say this is I is equal to Im sin theta. As well as here, this wave is E is equal to Em sin theta. So kahit anong i-name nyo dito sa 4 na to, papada. Letter B, find the value of the current after 1 all over 360 second. So substitute lang natin yung 1 over 360 second dito sa equation natin, sa time. So, kuha tayo ng isang equation dito na pwedeng pag-substitutan ng time. So, I is equal to 12 sine 376.99 times 1 over 360. So, that is at this time, 1 over 360, ang instantaneous current niya ay 10.3923 amperes. So, 10 point something. Siguro nandito. Tapos, ang time dito ay 1 all over 360. Next, time taken to reach 9.6 amperes for the first time. So, for the first time, kunana, means, anong time na marireach niya yung 9.6 amperes. So, let's say, this is ito yung 9.6 amperes. So, what will be its time na ma-reach na niya to for the first time? So, kasi, 4 na times niyang ma-reach ang 9.6. First time, second time, at the half cycle, negative half cycle, third time, and the fourth time. Diba? Kapada kita. So, at the first time, so this one is the first time. So, how will we solve that? Substitute lang natin yung 9.6. From our equation, ang instantaneous current natin ay I is equal to 9.6 amperes. So, I is equal to Im sine 2 pi ft. So, sine 2 pi ft is equal to I over Im. Sine 2 pi f 60t is equal to 9.6 over 12. So, sine 376.99t is equal to 0.8. Solving now, your time is the arc sine of 0.8 divided by 376.99. So, that is 2.122 milliseconds or 0.002122 second. Ito yung time na marireach niya for the first time, yung 9.6 amperes. So, nandito. Pag second time dito, anong time niya marireach? Third time, fourth time. Cycles or cycle. So, one complete set of positive and negative values of alternating quantity is known as cycle. A cycle also be sometimes specified in terms of angular measure. In that case, one complete cycle is said to spread over 360 degrees or 2 pi radians. So, in a sine wave, one complete cycle has a positive half cycle and a negative half cycle. So, this one is a one cycle. So, if we have 60 cycles per second or 60 hertz, so you will have 60 positive, negative, and so on and so forth. So, this one is one cycle. And one cycle spreads over 360 degrees. So, this is 360 degrees or 2 pi in radians. Time period. The time taken by an alternating quantity to complete one cycle is called time period or T. For example, a 50 Hz alternating current has a time period of 1 over 50 seconds. So, the time period of this one cycle is, since this is one cycle, T is equal to 1 all over F. So, 1 over 1. So, 1 second. If you have a frequency of 60 Hz, you will have a time period of 1 over 60 seconds. Okay? So frequency is the number of occurrences of a repeating event per unit of time. We can calculate also frequency by P times N over 120, where P is the number of poles of a generator or alternator. N is the speed in RPM. So example, we have an alternator has 6 poles. At what speed must the machine be driven to develop 60 cycles, 25 cycles? What frequency is developed if the speed is 1000 RPM and 1600 RPM? So we have number of pole is 6. Ang unknown ay speed. The frequency is 60 Hertz and 25 Hertz. From our formula, F is equal to Pn all over 120. So, ang unknown ay speed. N is equal to F 120 all over P. So, frequency is 60 times 120 divided by number of poles is 6. So, the speed will be 60 divided by 6, 10 times 120, 1,200 RPM. For 25 Hertz, we have N is equal to 120 times 25 divided by 6. So that is equal to 500 RPM. What frequency is developed if the speed is 1000 RPM? So N is equal to 1000 RPM. Frequency is equal to Pn over 120. So frequency at 1000 RPM is number of poles 6 times 1000 divided by 120. That is equal to 50 Hertz. Next, 1600. So frequency is equal to 1600 times 6 divided by 120. 80 Hertz. So amplitude, the maximum value in positive or negative of an alternating quantity is called an amplitude. So let's say this is our sine wave. The maximum value here it is what we call the amplitude or the maximum current, maximum voltage, power. So this is amplitude at positive half cycle and amplitude at negative half cycle. So we go now to vectors and phasors. So in DC circuit, numbers that have magnitude but no direction. So in DC circuit, wala siyang direction, only the magnitude. But in AC, we have the magnitude and direction. So that is the what we call vector. So vector is a quantity that has magnitude and direction. The sinusoidally varying alternating quantity can be represented graphically by a straight line with an arrow. The length of the line represents the magnitude of the quantity and arrow indicated is its direction. Similar to vector representation, such line is called a phasor. So vector is has a magnitude and direction. So vector, example, we have an arrow. The length of this arrow is what we call the magnitude. And the direction of this arrow, of course, it is the direction. Example, we have our reference here will be the x-axis. So this is our reference, x-axis. And we have a vector here. Let's say this one. So the vector has its magnitude and direction is going to the right, upper right. So if you have, for example, 1 ampere angle, 1 ampere angle 0, and 1 ampere angle 20 degrees. So how can we draw its vector diagram or the phasor? So 1 angle 0, 0 is at reference. So the magnitude of the vector is 1. Let's say this is 1. And since it is at the reference angle 0, so nandito siya. It is in phase with the x-axis. So this is 1 angle 0. While the other one, it has a magnitude of 1 and the direction is 20 degrees positive. So this is our x-axis, our reference, and 1 angle 20 degrees is here. So this is 1 angle 20 degrees. We have angle here equal to 20 degrees. Okay? So magnitude again, if you have 1 angle 15 degrees and another one is 5 angle 15 degrees. So if you plot the vector diagram of these two, of course the magnitude is shorter here because it has only 1, and the magnitude here is 5, longer than 1. So 15 degrees, let's say this is our reference x-axis. So 1, this is 15 degrees positive. And the other one is 5. Of course, it is much longer than the other one. So this is 15 degrees. And this is 5 in magnitude. It is either power, voltage, current. So note, the phasors are assumed to be rotated anti-clockwise direction. The phase of an angle of an alternating quantity at any instant is the angle phi in radians or degrees traveled by the phasor, representing the alternating quantity up to the instant of consideration measured from the reference. So let's say this is our reference, the x and y axis. We will read the direction of the vector to be positive at anti-clockwise direction. Pag dito ka nagbasa ng direction, negative. So let's say you have example 5 angle 20 or 5 angle 45. This is 45 degrees. This is 5. So if you read at the counterclockwise direction, you will have a positive angle. So 5 angle 40. But if you read at the clockwise direction, you will get this one. a negative angle. So, what will be the value of this angle? So, that is, this is 180, 90, and then 45, 90 minus 40, or 360 minus 40 degrees. So, you will have an angle here equal to 360 minus 40. So, that is equal to 320 degrees. You will get here when you read at the clockwise direction equal to 5 angle negative 320 degrees. Positive counterclockwise, negative clockwise direction. A while ago, we have our example 5 angle 40. So what about if we have an example negative 5, the quantity 5 angle 40? How will we plot its vector? So remember our Cartesian coordinate plane. This is positive x-axis, positive y-axis, negative y-axis, and negative x-axis. So 5 angle 40 is here. 5 angle 40. So saan natin ilalagay yung negative, the quantity 5 angle 40? It is just the negation of 5 angle 40. Negation. So, opposite direction of 5 angle 40. So, nandito yung 5. Since this is also negative kasi nakaparenthesis siya, ang reference mo dito ay etong negative x-axis. So, this is negative 40 degrees. It is just the negation of positive 5 angle 40 degrees. So, since this is our reference positive x-axis, what will be the value of the angle from our reference positive x-axis to this point? So, what will be this angle when we read it in positive anti-clockwise direction, and what will be the value of the angle at clockwise direction? So, this one. At negative clockwise direction. So, for positive clockwise direction, we have 5 angle, since this is 40, and from our reference to the negative x is 180. Deto'y whole. So, 180 plus 40 is 220. So, that is 5 angle positive 220 degrees. In our negative clockwise direction, we have 5 angle 360 minus 220, diba? 360 minus 220, or 45 plus 90 minus 40. So, dun na lang tayo sa 360 minus 220. So, our angle here in negative direction is 360 minus 220, that is 140 degrees. So, you can try this one in your calculator. You will input para makapunta kayo sa complex, kasi this is a complex mode. Mode 2. So, naka-complex na yan. And then, i-type nyo ang negative 5 angle 40. So, angle is shift may angle na nasa calculator nyo, nabura na kasi yung yung mga nakalagay dito sa calcu ko. So, hanapin nyo yung angle yung symbol na to sa calculator nyo. So, I am using Casio FX991ES Plus. So, if you input this quantity in your calculator, so negative 5 angle 40 equal to, at first you will get a rectangular form. Rectangular, negative 3.8. Kasi eto, dapat tapos nyo na sa advanced math ninyo. Before kayo nag-circuits 2, dapat may knowledge na kayo sa complex numbers. Negative 3.830 minus J 3.214. So this is in rectangular form, what we call a rectangular form. J is representation of an imaginary number. So sa calcu nyo ay yung nakalagay. Pero ang ginagamit namin sa EE is J. So you will get this rectangular form, and then click nyo yung shift 2, 3, then 3. You will get 5 angle negative 140. So, ang binasa niya ay yung clockwise direction. Ito. 5 angle. So, this is negative. Kasi, anti-clockwise direction pala. Lagyan mo ng negative to. This is positive. Kasi, nagbasa ka sa counterclockwise direction. Okay? So, if you have any questions regarding this one, you can message me. And we will have a discussion further if you have any questions regarding sa pag-input sa calculator.